Methods for fast skeleton sketching. Our application supports both freehand strokes and polylines. We also added basic gestures support. Cut, to add fixed joint in the skeleton. Trim, to remove part of a stroke. Reverse, to change the direction of a stroke. And delete. Strokes can be overdrawn to correct mistakes, or simply to change the look of the curve. Stroke embedding is a major feature in our application. Freehand strokes are fully and correctly embedded inside the volume, regardless of overlapping geometry. For complex mechanical models, we have an option to treat each object as a whole. This means that embedding won't stick to folds or bends of the surface, but will rather move to the center of each part as desired. To create bones from the sketches, we provide 3 automatic subdivision methods. One to subdivide into segments of equal length, another to subdivide adaptively based on curvature, and one to subdivide into a fixed number of segments. Finally, we create the bones using the convert gesture. The most powerful bone creation method, however, is templating. On the original leg template, we can see a pole target for the knee, IK solver on the foot, as well as a foot roll control. As we draw, the name of the current bone changes. This example uses quick stroke, so the template is automatically applied when the stroke is finished. We had to slightly adjust the heel pivot since the foot is more flat than in the template. As demonstrated, all controls work correctly after retargeting. Our second template is for fingers. It allows us to demonstrate template renaming. Automatic template renaming means you can draw multiple copies of the same template and each will be named appropriately. These finger flexors use action constraints, which rely on a precise naming scheme. Template renaming gives us all the control needed on bone names. This last example shows an IK-FK arm template. Such a setup uses multiple copies of the bone chain, all of them being correctly retargeted by our system. In FK mode, each bone is controlled individually. When the control is in IK mode, a chain target bone and a pole target bone control the pose of the skeleton. An object controls the interpolation between the FK pose and the IK pose.